All right, so we're going to be solving by square roots today. So we're solving quadratics by square roots. So we need to review quickly the idea of simplifying a square root or a radical. So what's the square root of 49? 7. Why? Because 7 times 7 is 49. Okay, so there's a pair of 7s inside of a 49. Is that important? Because what if you're doing the square root of 18? Not a nice number, right? If it was 16, yeah, it'd be 4, but it's 18. So when you're trying to find the simplified square root of 18, not the decimal, not the simplified square root, exact solution. So you're looking at, 6 times 3, 3 times 2. There's a pair of 3s. So it would be 3 radical 2 out of that. Okay. Now, depending on who you had for Algebra 1, which way they showed you how to do this. This is how I teach it, is with factor trees. If you had Coach Mack, I think he just says divide it by square numbers. And you would say, well, what square number goes into 18? 9. What's the square root of 9? That's the 3 that's out front. 9 times 2, that's the 2 that's on the inside. I think the factor tree method is superior, not because I teach it that way, but because you can use it when we get to larger roots, like if you're doing cubed roots or fourth roots or stuff like that. You can still use the factor tree method without having to memorize what are all the cube numbers, what are all the fourth power numbers. Not everybody memorizes those things. I don't have every square number memorized, but I can break a number down with a factor tree no matter what it is. I can do something with it just out of knowledge of numbers. Square root of 32, if we're going to simplify that. I know a square number that goes into it. Let's pretend I don't know a square number that goes into it. I know 2 goes into it. How many times? Because it's even. 16 times. Well, it happens to be a square number there, but let's go ahead and break down the 16 a little further. That's 8 and 2. That's 4 and 2. And 2 and 2. So I keep breaking that number down until it's all prime numbers at the end. And then I just look for pairs. There's a pair of 2s. There's a pair of 2s. Here's a 2 that's left out. So I have 2 pairs of 2s. So that's 2 2s on the outside. And then this 1 2 that I've got an arrow pointing to there, that's the 2 that's left on the inside. So that ends up being 4 square root of 2 in its simplified form. Okay. So it's got to have a pair to come outside. If it doesn't have a pair, it stays on the inside. A weird number like 140. I don't know much about 140. I know it ends with a 0. So that means what number goes into it? 10. So that's 10 and 14. I know 10's not prime, so I'll break it down to 5 and 2. I know 14's not prime. It's 2 and 7. And I have a pair of 2s. So what comes to the outside? A 2. What's left on the inside? 5 times 7, which is 35. So it's 2 radical 35 out of that. So there, I may not have known, hey, 4 goes into 140, but I did know that 10 went into it, so I could break it down. So not knowing your square numbers, using the factor tree, you don't have to know them. I mean, honestly, you just got to know, be able to count to 2. That's pretty easy. I can do that. Square root of 72. This is one that comes up quite a bit. What do we know multiplies to be 72? 8 times 9. One of those is a square number. The other one is not, but I'm going to break down both numbers as far as I can. So that's 4 and 2. Another 2 and 2. 9 is 3 and 3. So I have a pair of 3s, and it doesn't matter which pair of 2s you pick. I'm just going to pick those 2 that are together. And I have a pair of 2s and a pair of 3s. So what comes to the outside? 3 times 2. What's on the inside? 2. There's a 2. That 2 right there doesn't have a buddy. So he's got to stay in the house. Leave him inside. So that ends up being 6 radical 2. Simplifying square roots out of that. Go go ahead and do an operation with square roots. Let's say we have square root of 10 times the square root of 15. When you're multiplying, maybe you remember doing this from Algebra 1, or maybe even you do this a little bit in geometry. How do you multiply square roots together? Hopefully without inside times inside. If there's anything on the outside, it's outside times outside. So here we don't have anything on the outside at the moment. So we're just going to multiply the insides together. So that'd be 10 times 15. That's pretty easy math. That's 150. But we're simplifying, so we want to try to break that down if we can. We know it's a square root of 150. I got that from 10 times 15. So I'm going to use that. I'm going to have to think too hard here. 5 and 2, 5 and 3. And then there's a pair of 5s there. So that's going to be 5 radical what? 2 times 3, which would be 6, yeah. Definitely wouldn't expect you to write that step every time there. I mean, you can obviously do that with your, with your brain. Okay, so multiplying radicals, inside times inside, outside times outside. So if you had something like this, and it just went off. Awesome. And back. All right, 2 radical 6 times 3 radical 14. So here we got something on the outside. Not that this comes up a ton when we're solving, but it is, something that we need to be aware of just for simple, number simplifying stuff. So inside times inside, outside times outside. So on the outside we got 6 radical 84. 6 times 14. 60 and 24. And then we want to simplify that.